Hi everyone, this is Kona, and I'm going to go through this regression activity. These, number 1 and 2, should help you with definitely one of your quizzes, and then the rest of this down here should help with your other quiz. So what type of correlation is this? So positive, negative, or none. So 30 pairs of values have a correlation coefficient 0.669 with a p-value of 0.105. So first of all, the only thing you need to look at initially is this p-value. Is it greater than 0.05? Yes, it is. Then it's none. You don't even need to look at the correlation coefficient. So here, it doesn't even matter how many pairs of variables, doesn't even matter this right now, just look at this p-value. Is it less than 0.05? Yes. Then you look at the R value. Our R value is greater than 0, which means it's positive, so it's positive there. So here, basically ignore everything except the p-value. Is that less than, oh, it is less than 0.05. So then we look at our slope in this case, which you can use. Before we were only dealing with R, which is our correlation coefficient. Slope will work the same way. So if our slope is negative, so slope is less than 0, then it's a negative slope. If our slope was positive here, so if it was just 14.12, then it would be positive. So here, once again, just go straight to that p-value. It's 0.23, that's greater than 0.05, so that's a none. Doesn't even matter what the slope is. So should the calculated regression line be used for estimation? This is super quick. Ignore basically everything here for the should it be used for estimation for the regression line. All you have to look at is the p-value. So is the p-value 0.015? Is that less than 0.05? Yes. 0.051, is that less than 0.05? No. P-value of 0.49, is that less than 0.05? No. P-value of 0.028, it is less than. There's yes. So yes, no, no, yes. That's all you have to do is just look at these p-values and decide if it's less than 0.05. So hopefully the quiz with these questions should be really quick, easy, and a great score for you. So calculate the slope and y-intercept of the following data. So what type of correlation is this? Well, if you look at this p-value of 0.062, it's greater than 0.05, so it's not a correlation. It's so close to 0. So should the calculated regression line be used? Well, because that p is greater than 0.05, no. But we're going to go ahead and find it anyway. The slope is going to be 0. Why? Because of that p-value being so high. So slope is 0, which means when we go to put the y-intercept in, we've got our mean y, which is our 500.70, but because our slope is 0, the mean x doesn't matter, and so we just get our y-intercept is equal to that 500.70, which is our response y. So that one's a quick, dirty, easy one. Calculate the slope and y-intercept of this data. What type of correlation is this? Well, our p-value is 0.008, which is less than 0.05. Because that p-value, so then we can look at the correlation coefficient, which is a negative 0.619, so that's how we know it's negative. Should the calculated regression line be used? Yes, because our p is less than 0.05. So put in our slope, because in this case, our slope is a real value because our p is less than 0.05. So it would our R value times our standard deviation of y over standard deviation of x to get that negative 14.075 for our slope. We then take it and plug it in over here to our slope value. And why does that not work? Oh geez, I think I went straight to the mean x slope. You know, I'm not sure. Hold on just a second. Okay, so that's totally my mix-up. I put the R value in instead of the slope, but the answer is correct. So ignore my mess up of the negative 0.619 and put the negative 14.075. So X that out, put the negative 14 in, and this is the correct answer. So I apologize. Yeah, see, that's what happens when you get going too fast. You make little silly mistakes like that. So sorry, take out the R, put in the slope, and you will get this answer. So moving along, 35 pairs have a correlation coefficient of negative 0.29. What's the value of the test statistic? So for this one, this is where you put in the negative 0.29 over the square root of 1 minus that R value over n minus 2. And just to see this one, I went ahead and did it on the calculator. It's not the first one, it's the second one, the negative 0.29, just to show you Here are all of the different parentheses you need to put around it. So tons of parentheses. If you put all the parentheses in the right place, you will get that t-value of the negative 1.7407280093. So there are all the different parentheses you need. Once you get that, you then have your t-value, degrees of freedom, which is your 35. That's your 35 from up here, minus 2. You can then find that p. Remember, we find the p using the probability table. So degrees of freedom, we said, was 35 minus 2, so 33. Our t-value here is negative 1.7407280093. Click calculate, and we're using the both sides, and that's where we get this value right there. So the 0.091049, which is right there. So based on that p-value, what type of correlation is this? Well, that p-value is greater than 0.05, so it's not a correlation, so it's a none. And should the calculated regression line be used? Nope, because the p is greater than 0.05. So here's our last example. 20 pairs of values have a correlation coefficient of 0.56 with the value of the test statistic. 0.56 divided by square root of 1 minus 0.56 squared over 20 minus 2 is the 2.867712716. What's the two-tailed p-value? The t is this value right there. Degrees of freedom, remember, is 20 minus 2. And then we're just going to, oops, sorry. There we go. Here's that probability. Hold on. Okay, sorry about that. So what we do, our student t, our degrees of freedom, in this case, were the 20 minus 2, so 18. Our t-value in this case was our 2.867712716. Calculate. We are using both sides, and that's the 0.010234, which that's we have our p-value. So based on this, what type of correlation is this? It is positive, or it is, first of all, we do have one because our p is less than 0.05. We then look at the r value, which is our correlation coefficient is 0.56. 0.56 is positive, so we've got positive. Should the calculated regression line be used? Yes, because our p, this value right there, is less than or equal to 0.05. So we're good to go. And there are all of the answers for the regression activity.